Okay, guys, so this is a continuation of the previous lecture of May June 2009, paper 1, chemistry, AS level chemistry. Okay, so let's get started from 21 to 30. We've covered the MCQs number 11 to 20 in the previous lecture. The link to that is given in the description, so check that out if you haven't checked it yet. Okay. Now, let's get started, which always applies to nucleophile. Okay, nucleophile is any species with at least one lone pair. This is a definition of nucleophile. So it attacks a double bond, it has a lone pair of electrons is your correct answer according to the definition of a nucleophile. Then trichloroethanoic acid is used in cosmetic surgery to perform a chemical peel to remove dead skin. Trichloroethanoic acid can be made by reacting chlorine with ethanoic acid. What is the mechanism? Okay, this is the ethanoic acid. And how can all the hydrogens get replaced with three chlorine atoms to form your carboxylic acid? So trichlorocarboxylic acid, trichloroethanoic acid. So this is actually a free radical substitution because the hydrogens can only be replaced with chlorine in presence of UV light by free radical substitution mechanism. Right, then moving on to the next part, polymerization of chloroethene gives PVC. How does the carbon-carbon bond in PVC compare with chloroethene? Chloroethene is actually uh, an alkene with a chlorine atom attached, with one chlorine atom attached. This is a double bonded carbon compound, whereas PVC is a single bonded compound. So the carbon-carbon bond length over here, since it's single bonded, so it's gonna be weaker. This bond is going to be weaker, and plus it's also going to be longer because weaker bonds are longer as compared to the stronger bond. So this is going to be a stronger bond. Double bond is stronger than the single bond, so it's going to be longer and weaker. Okay, so the carbon-carbon bond in PVC is going to be longer and weaker. Now, in the hydrolysis of bromoethane by aqueous sodium hydroxide, which is the nature of the attacking group and the leaving group. Okay, this is actually a nucleophilic substitution reaction, and since it's a primary alkyl halide, so it's actually SN2 mechanism. So now, since one is called nucleophilic substitution, so one nucleophile comes and the other nucleophile leaves. So both of them are actually nucleophiles. This is nucleophilic substitution. Moving on to the next, which reaction would not give propene as one product? Okay, propene as only one product. Okay, which of them will not give propene as one product? Okay, add in an excess of concentrated sulfuric acid to propanol. Okay, if we add excess of concentrated sulfuric acid to propan-1-ol, what would happen? We'll get propene as a product because propan-1-ol is an alcohol. It will get dehydrated to form an propene molecule because sulfuric acid concentrated at 180 degrees Celsius is a dehydrating agent. Adding warm aqueous sodium hydroxide to bromopropane. Okay, this is actually adding a nucleophile to bromopropane. Okay, if we add a nucleophile to bromopropane, we'll get propanol. If we add sodium hydroxide to bromopropane, this is bromopropane, CH3, CH2, CH2, Br, and if the nucleophile OH negative comes and attacks it, it will replace the Br and form your propanol. So B is the answer. It will not form propene. Then going on to 26 is about glycol, which is an antifreeze, has this formula, can be oxidized to give a number of products. Okay, it's an alcohol, so and primary alcohols, two primary alcohols are there. From theory, we know that primary alcohols can be first oxidized to aldehydes, and that these aldehydes can be further oxidized to carboxylic acids. Now, this is what the theory tells us. Now, let's see. It says that which on oxidation does not react with sodium. By the way, aldehydes do not react with sodium, so they are actually asking us this intermediate compound. Okay, so aldehyde. This aldehyde has the simple molecular formula as C2H2O2. So A is the correct option. Which ester is formed when alcohol is reacted with butanoic acid? Okay, this is butanoic acid. That's your propanol. Okay, the butanoic acid will leave its OH group and the propanol will leave its hydrogen atom, and both of them will combine to form a water molecule that will be eliminated and an ester bond will be formed. And so since the acid is 4 carbon, so it's going to be butanoate, and since alcohol is 2 carbon, it's ethyl, alcohol comes first, so its name is going to be ethyl butanoate. Then going on to the next MCQ. Okay, carbon gives the characteristic flavor of caraway and spearmint. Okay, prolonged heating of carbon with hot concentrated acidified manganate produces carbon dioxide and compound X. Okay, X contains 9 carbon atoms and reacts with 2,4-D and pH. Sure. What is the maximum number of molecules of 2,4-D and pH that will react with one molecule of X? Okay, 2,4-D-pH is a test for carbonyl compounds. So the greater the functional groups, the greater the aldehydes or ketones, the greater the moles of 2,4-D-pH required, and the greater the moles that will react with it. If we react with hot concentrated acidified potassium manganate, what it does is that it actually breaks the alkenes. It cleavage of the carbon-carbon double bonds occur in alkenes, and we get characteristic products. Okay, the three characteristic products depend upon the configuration of the carbon atom. If this carbon atom, which is double bonded, is attached to two alkyl groups on both the sides, it will form a corresponding ketone. If it is attached to one alkyl group, and if on the other hand it is attached to a hydrogen atom, it will form a carboxylic acid. And if it is attached to two hydrogens, it will form the carbon dioxide. This is where the carbon dioxide came from in this question over here. Carbon dioxide came from this compound. Okay. Now, if it breaks, so this carbon atom will give you a ketone because it's attached to two alkyl groups. You already have one ketone in there as well, and this carbon atom will also give you a ketone. So we have three ketones in there, and this carbon atom will not give you a ketone. This will actually give you a carboxylic acid because you have this configuration. So we have three ketones, so therefore three molecules of 2,4-D and pH are required, and for C is the answer because 2,4-D and pH only reacts with carbonyl compounds. 29. 2-methyl-butyl-1,3-diene is used as a monomer in the manufacture of synthetic rubbers. Which compound would not produce this monomer when treated with concentrated sulfuric acid at 170 degrees Celsius? Okay, they are actually asking us the conditions which they have given are for dehydration. So they are actually asking us that which of these compounds will not form this compound on dehydration. Okay, it's actually the shortcut to this is you go in the reverse direction. It's this compound, right? They're asking us the dehydration from alcohols to alkenes. How about hydrating the alkene to form the alcohol? So if we hydrate the alkenes, how if we hydrate the carbon-carbon double bonds in there? So the first double bond that we hydrate, the H atom will go to the terminal carbon atom, and the OH will go to the secondary carbon atom according to Markovnikov's rule. So you'll get a secondary alcohol in here, and the same case goes for the other side as well. You'll get a secondary alcohol and a terminal CH3. So this is the compound that you get, and it's option A. Okay, two CH3s, one OH, and then CH, and then CH3 and OH. All right. Then going on to the next question, MCQ number 30, a compound Y has the following properties. What could Y be? Okay, it is a liquid at room temperature and atmospheric pressure. It does not mix completely with water, does not decolorize potassium manganate. Okay, not decolorizing potassium manganate actually suggests that it is not an alkene. Does not completely mix with water suggests that it is a non-polar compound. And is a liquid at room temperature and pressure would actually mean that it has a low melting point. Alright, so what about ethane? Does not completely mix with water. What could be compound Y? Okay, and it does not completely decolorize potassium manganate. Okay, ethane does not. Ethane is a gas at room temperature. Okay, the first option is not met, so it cannot be A. Ethanoic acid is a liquid, but it does mix in water because it can form hydrogen bonds with water, so B cannot be the answer. Same goes for C because it can mix with water and does not give uh, and also decolorizes acidified potassium manganate because alcohols can be oxidized. So the only option that is left is this ester ethyl ethanoate. Alright, so that's it for this lecture, guys. The next lecture from MCQ number 31 to 40 will be done in this lecture, and the link to that lecture has been given in the description. Thank you so much.